Hey y'all, it's Andrew Couch here, and today for this Tidy Tuesday, I'm actually not going to be analyzing the Tidy Tuesday project. Instead, we're actually going to go over the TidyModels package. So recently, the Tidyverse developers and data science team has released an ensemble package called TidyModels, and it's essentially a it's like the Tidyverse except for machine learning. So you can do all these modeling procedures in one package. Um, this is actually the successor to the Caret package, which was kind of like the default black box modeling package, where you could train multiple models at this at a single like framework. And Max Kuhn, who's actually the developer of the Caret package, is on this team. So TidyModels from now on is going to be the successor to the Caret package. So I think it'd be interesting to kind of go over the basics of TidyModels and just kind of do like some comparing and contrasting with TidyModels and Caret. So we're gonna use the abalone dataset, which is a pretty popular kind of like toy machine learning dataset. It's by I guess UC Irvine's machine learning repository, and you just need to go to the data folder and download the abalone.data file. Okay, so we're just gonna open up a markdown file. We're gonna rename this to Tidy Tuesday, Caret, and TidyModels. Okay. I'm gonna make sure to let's see here. I'm gonna make sure that I have my directory set so I can get it set as working directory. Okay, sweet. Okay, so I'm gonna do the I'm gonna load in the Tidyverse, TidyModels, and the Caret package. Okay, and also I'm gonna do read underscore CSV, and it'll be abalone.data. And since for the abalone data file, it doesn't actually have column names. It's mostly just like it's like that. We're gonna have to specify the actual column names. And if we look at the column names, it's all of this stuff. But I actually have the list saved, so I'm just gonna copy and paste this in to not waste any time. Boom. Okay, so now we have this, and with the abalone data set, it's actually I believe a regression data set where you're trying to predict the amount of rings in the abalone. And the rings is essentially, I guess, your age of the abalone. I guess it's like a muscle or something like that. Abalone. Yeah, it's like it's like a snail. Okay, and I guess the rings are kind of the age of it. Cool. We're just gonna do some basic pre-processing. So df, we need sex to be as a factor. So we'll do that. Additionally, there's about 4,000 rows, and since I'm going to be doing some modeling, I'm going to just remove some of it. So I'm going to do set seed, and I'll say 80, say df sample and df size, and I'm just going to use 800 samples. It's not really a great, I wouldn't probably do a bunch of machine learning models on just a sample size of 800 without doing some type of procedures for it, but this is just for comparing, so we're not gonna lose sleep over that. Do a basic summary statistics of it. We have a length, diameter, height, hole weight, shucked weight, viscera weight, shell weight, and then the rings with a min and a max of 224. We also have relatively even genders, so there's not a disparity between that. F, I, and M, female, male, and maybe I is just kind of like unknown, so we can go through that. Infants, so infant, cool. Okay, I bet infant is gonna be related to the rings, but that's not really what we're trying to go over. Okay, so modeling procedure 101 is you first have to create your training and your test sets, right? So you want to train a model off of the training data, and then you want to evaluate it based off the test data. Okay, so we're gonna do it. First, we're gonna do it the Caret way. So with Caret, you just make you use the data partition, function. So we'll say caret split create data partition y. So df we'll say rings p equals point. We'll do 80-20 split. List equals false. So we have a caret split, right? So as always, like resampling stuff going on. It's okay. We don't want to go through that. Okay. So to create the test train and test splits, we'll do caret train, and then we'll say df, and we'll index the rows by the caret split. Okay, that's fine. This is just kind of like an argument about like tables and stuff like that. We don't really need to worry about that. Test, we'll make a test set, and we'll say whatever you did for those rows, we're not going to use those rows that we're using in the train sets. So we say minus split. Okay, and if we see caret train dimensions 641 with 9 columns, which makes sense, and then we do the test 159 9 columns. Cool. So that's the caret way to do it. So splitting train and test sets with caret. And then we have the TidyModels way, which is use initial split, right? And what's interesting about TidyModels is most of all these kind of like steps and processes and actual modeling are in different packages. So there's a package for just like doing data partitioning, right? There's a package for actually tuning your parameters, and there's like a package for making the models, and there's another package to do on the evaluations. So it's kind of interesting, but you don't really have to worry about like which package goes with what thing. It's all in the TidyModels central package. Okay, so we're gonna call this tidy split, and we'll say initial split, and it just takes a data. So we'll just say df and prop equals, and we'll say 0.8. And what's cool about I guess this is it's a little bit easier to understand what's going on. So to create the train set, you don't actually do this. You just say training, and you give it the split from it, and then you for test you do testing, and you give it again the same split. Okay. So if we look at tidy train dim, it's 641. Same thing, right? Okay. So that's the tidy way. So splitting train and test sets with tidy I'm going to say the tidy way. Okay. So when we're starting, it's nothing crazy, I would say. Basically the same way, pretty efficient on both ends. Honestly, I wouldn't really lose sleep if you did this way or that way. But I kind of like this because you can use this actual split for other things in the tidy framework. Okay. So once we have our training and test sets, we actually need to apply some pre-processing. Most models, it really doesn't hurt to, center and scale or normalize your data since they're on different dimensions. For this one, it's pretty much, I would say, centered, but we can just keep on doing it. So with the caret way, what we're going to have to do is we're going to apply center and scaling to all values besides our target variable, which will be rings. And we also have to create dummy variables for the sex. So that's just going to say like female equals 0 or 1, right? And we're going to do one-hot encoding because we're going to do a random forest model. And normally if you're doing like a logistic linear regression, you should probably do like a dummy variable thing where you have some degrees of freedom, where it's only if you have 3 categorical values, it would be 2, so it'd be female, male, and then if female and male were 0, then it'd be implying it'd be infant. But this way we're just going to do it very simple. It'll be female, infant, or male. 0s and 1s for all of them. Okay, so we're going to say pre-processing center, scale, and one hot encode. Okay. Okay, so first we're gonna do to do the pre-processing with Caret. We're actually gonna use the pre-process function, which is pretty simple. So we'll say, since we're gonna be modeling it using the training data, we're always gonna use the training stuff so we can apply it to the test set. We don't really want to have any data leakage, so we wouldn't want to do the pre-processing values on the entire set, if that makes sense. Ideally, the splits will make it so it shouldn't make a difference, but it's better to just do it based off the train set, and you should never really use the test set for any modeling stuff. Okay, so we're going to deselect the rings because we don't want to apply the pre-processing to the rings. So we'll do that, and then we'll say method equals center and scale. So there, right? It's pre-processing, center, scale, yada yada. Okay, so Caret Pre-process. Okay, and we're gonna apply that into a little object. And this is actually some type of like, you can use this to predict onto it or to kind of like apply the actual pre-processing. So we'll say Caret train equals predict Caret pre-process, and we'll use our Caret train data. Okay, so we apply, ooh, I just spelled Caret train wrong. Caret train, and then we'll do the same thing to our test set. Pre-process. Okay, boom. So we applied pre-processing using our training data on both our train and test sets for our Caret modeling service. So if we look at our Caret train, we still have our categorical or factored variables. So we still need to apply the one hot encoding. So we'll say apply one hot encoding using Caret. And with Caret, they use the dummy vars function, and we'll say dummy vars data equals Caret train. So that's saying if we see a factor, we're gonna create it into a dummy variable. And there's an option to make it so it's not one hot encoding. I think it's called drop second. So we can say like, oh, we can say drop, what was it? Keep? I don't know. It's something like that where it's like drop second equals true, but we don't really need to worry about that since we're not going to be doing that. So, okay, Caret one hot dummy vars, boom. Okay, so now we're going to do, we'll just apply this one hot encoding to all of our data. So Caret train, see, one hot encoded, everything is still centered and scaled. And then we still have our rings which are untouched. Okay, so we'll say Caret train, boom, Caret test. Do the same thing to our Caret test data, to our Caret data. Okay, so that's our pre-processing that we're gonna do for modeling with the TidyModels. So we'll say tidy way of pre-processing. They actually use a thing called the recipes package, which has all of these kind of like pre-processing styles, and they do it in like steps. And essentially what it's saying is this pre-processing is basically a recipe where you're trying to like add different ingredients to it to create your final model data. Okay, so the recipe starts with recipe. We have to specify our formula. So recipes is we're going to predict rings using the formula. Our data will be our tidy train data, and then this is what's really cool is since it's the tidy models, it's basically made to be piped into things. So what we're going to do, we're going to add center, and we're going to say all predictors minus all nominal. And all nominal is like all categorical variables, I guess. So we don't want to apply the center and scaling to our dummy variables. And then we're going to do step scale, same thing, all predictors minus all nominal. And then step dummy, all nominal minus all all nominal. And then we also don't want to apply it to let's just do it. And then we'll say one hot equals true. Cool. So now we have a recipe. So it's saying, oh, centering, scaling, dummy. Okay, and then we have to prep. So there's things where I'm not really sure how this works, but basically this is the recipe where it's also not really doing anything, right? It's just saying like, here's what we did. We actually have to prep the recipe. So we'll call this tidy prep equals prep tidy rep. Okay, oops. Oh, I need to call this the tidy rec. Tidy, I'm gonna call this tidy rec or tidy recipe, right? Okay, boom. So we have our recipe prepped, right? So now it's really saying, it's like, okay, here's what's going on. We're gonna center and scale these things, right? We're gonna scale these again, and then we're gonna create dummy variables from the sex, right? So that's now it's looking at their data and saying, okay, how am I gonna apply this recipe? What are the predictors? What are the nominals? What is everything, right? And then we can also say tidy juice, which if you notice, we don't actually have anything. It's just saying like, outcome predictor, like where's my actual pre-processed data. That's when we have to juice our data, and we do juice tidy prep, and boom, we have tidy juice. And then it applied all that stuff to it, where we have our one hot encoded variables, our center and scaled data with our rings that's untouched. Cool. So you can see that you might be wondering like, okay, well, what's the? I mean, it's cool that this is like able to be piped and stuff, but it's like, what's the point of how is the tidy way? How is the tidy models better than Caret? Well, for example, when we apply the center and scaling, we don't really know how it's supposed to be treating every variable. We might want to actually only center, say, our heights and only scale our diameters. And with the tidy way, we don't have to do all predictors. We can also say like starts with, contains, stuff like that. Or we could say, oh, all nominal. So there's more fine tuning in a more intuitive fashion. Where this Caret way is almost kind of like a black box where you're like, oh, just do it. You don't want to care how it happens. You just want it to do it. Okay, cool. Plus, these recipes, we just have center and scaling, but there is much cooler things for the pre-processing. Like if we look at our references, we have Hasbro, all predictors, all that stuff. So we have some stuff like that. We have imputations, impute a lower threshold, mean imputation, mode imputation, rolling window stuff. You can do more complex transformations. You can do box cocks. I don't even know what this is, right? Inverse logit. A lot of really cool transformations. You can do like a ReLU transformation on it, right? Again, and then there's also more things. So you can say like you can create dates, counts. You can do interaction effects. So there's a lot of really cool stuff that you can do, like step interact. So if I want to do, say, interactions between, the gender and diameter, we can add that if we wanted to. See, like terms equals carbon to hydrogen, stuff like that. So yeah, there's a ton of just really cool stuff where, I mean, you could go through like a month long education course about it, but we don't really care about that. Okay, that's just the basics of it. Okay, so now that we have our pre-processed data for both Caret and TidyModels, we're going to start doing our sampling procedures. So one of the ways that Caret's main framework is basically create a train and test set, and then with that train set, use k-fold cross-validation to figure out the best tuning parameters. So if you're in a modeling or data mining class, you might have heard of like, oh, we're going to do the train validation and test set. That's essentially what k-fold cross-validation is doing. So that's why they only split it into a train and test. The folds are acting as a validation set. And it's a little bit better because you can do it 10 times, so you have a more robust estimate of your error and hyperparameter tuning. Okay, so we're actually going to set our sampling procedures using k-folds. Okay, so for Caret, it's pretty simple. You say train control method equals repeated CV, repeats equals 10, number equals 10, and that's how you do it. So we'll say Caret k folds. Boom. Okay, so if we look at Caret k folds, we have all that stuff, right? Kind of dirty. You don't really want to read this stuff. It looks like there's a lot of, stuff in it. For the TidyWay, they use vfold CV, which is basically the same thing. So we'll say tidy train v equals 10 strata equals, I'm going to say rings because our thing is based off of rings. So tidy k folds. Boom. So again, it's not, and you see how, oh, it made the folds already, right? It partitioned it. Okay, so it's, again, not crazy. They're doing the same thing. This one, it's not actually giving you the data. It's going to do that in the actual modeling procedure. Whereas in the TidyWay, it already creates the data, and then we're going to put that k-folds thing into the actual model stuff. Okay, but again, pretty simple. Nothing's changed too much. However, for the actual modeling, then we kind of get into some different waters. Okay, so we're gonna say tuning models. Okay, so we're gonna do what would we do? The Caret first. We're gonna do Caret first. So we'll say Caret RF train rings. So that's our formula. We're gonna try to predict rings using our training data. We're gonna model it too. Our method will be random forest, which is the random forest package. We're not gonna use ranger or anything like that. And our train control is equal to caret cross, caret, what is it, k folds, and we're gonna just set our tune length equals 3. So it's gonna try 3 different, I guess, M tries, and this might take a while because I totally just did not enable parallel processing, but that's fine. Okay, so while it's training, we're actually gonna do, we're gonna start writing out the TidyModels way. So I'm gonna first say create a model, I'll say create random forest model in Caret. Okay, the random forest model in Caret is pretty easy, and honestly, I kind of like it better than the actual TidyWay because it's very straightforward, right? I think most people could read this and say, okay, I get it. Like, I get what you're doing, but it's not as flexible, right? So the TidyWay would be, we're gonna choose a rand forest, and how we're gonna tune it is we're gonna say, okay, we're gonna tune our M tree or M try, and we're gonna let the model TidyModels tune it. But we're also gonna give it trees, and for our trees, we're gonna specify, say, like, I don't know, 1,000 trees, and then min n, we're gonna let, again, TidyModels tune that thing. Okay, and then we're gonna have to set the mode, and since we're trying to predict a rings, which is like a continuous variable, we're gonna say, oh, it's a regression. And for our engine, we can set our engine to random forest engine. What's cool about this is we don't actually have to choose a random forest engine. We can actually choose, TidyModels. We can actually choose different engines, which is really nice, especially when you can think of how you might prefer, say, like Ranger instead of random forest and stuff like that. So if we look at, you see parsnip, right? You can set your engines. So yeah, you can set all this cool stuff. There's a model list too, so it's pretty easy to reference. They have like Keras stuff. See for random forest, they just have random forest. If you look at it for random forest, you can say, okay, these are the things that they give you. You can say ranger or random forest, and you can also use spark. Yeah. So if we also go back, we can see that there's also some cool things. So there's like you can do like a stand backend for linear regression. So if you're into that, like Bayesian statistics and stuff like that, you can do cool stuff like that. Okay. So yeah, as you can see, there's a decent amount of models. Some neural nets, k nearest neighbor. Let's see what else. There's multivariate adaptive regression splines, GLMs. Let's see what else are there. Yeah, and obviously your boosted models too. Okay. So let's see what it's still doing. Okay, it's still running. I'm gonna pause this video and then I'll resume it when it's at finished training. Okay, literally right when I said I'm gonna stop the video until when it finishes training, finished training. If you look at the timestamp, it's literally the same time. So we look at it, trained it using 3 different M tries. Great. It says like, okay, the best M try or best value was 6. So 6 M tree. Okay. So with the random forest model, we can just set that. So we're saying, okay, we're going to specify a random forest model. Okay, so we'll say tidy RF. And if you note something, it's just like, wait, but we didn't actually train anything. We just have a model skeleton. Okay. And this is the thing that's a little odd, and I think I'm going to have to start getting used to. We have to actually do a tidy workflow. It's basically saying, since we're giving it all these data splits, we need it to kind of understand how to model this stuff. So we give it a workflow. So we'll say, okay, our workflow is we're going to give it a recipe or pre-processing process, and that's our tidy recipe, and we're going to add a model. And that model is our tidy RF model. Okay, so we have a tidy workflow. So specify modeling procedure. Specify model. Okay, I'll say tidy way. Okay, and then finally, to actually tune it, we're gonna say tune the model. And to tune the model, we actually do the tune grid. We give it our tidy workflow. We give it our resamples or our like cross validation stuff. So that if we reference it, it's tidy k folds. And then for our grid search, we're gonna say grid. We'll say grid equals. We'll say grid equals 5. Okay, so we'll say tidy tune. Boom. So now it's tuning the models off of a grid that we created using k-folds. Okay, and if we're saying 5, tried 5 different things. So while it's training the models, we're gonna actually go and probably create a new section. And I will say evaluate the models. Okay. So we're gonna let this go. Actually, we might just keep on going through here. Oh yeah, that's what I also wanted to go over. Create pre-processing. It's okay. It's still going. One cool thing about the TidyModels package is it actually comes with some other things, such as where is it? Text recipes. So there's actually some text. They made it so it's pretty easy to actually do some text mining. So if you look at it, it says step tokenize. So it'll actually do all the tokenization for you. Remove the stop words. You can do like max n, and you can also do a TF-IDF thing right there. And this is because like a lot of the people who created this have also created the tidy text package. Okay. So if you notice, there's like, oh, you can do word embeddings, which is very, very cool. So you can kind of get some state of the art modeling stuff if you give it some word embeddings. Yeah, let's see if there's anything cool that we can kind of look at first before we go and look at it. Yeah. So one thing that I'm thinking that they're gonna try to do is with word embeddings, they might be able to embeddings. Where's the embeddings at? Is they do some cooler things, such as like with some like neural network, like Hugging Face stuff, but you never know. Okay. So our model has been trained. Okay, it says creating pre-processing data finalize. Okay, whatever. So if we look at TidyTune, we have all of our splits, all of our folds with a metrics and some notes. Okay, and it says, oh, we use 10-fold cross-validation using stratification. Cool. So first, we're going to evaluate our Caret model. So let's say evaluate Caret model. So Caret RF, pretty cool. Can we plot it out? Yep, we can plot it out. Best value is 6, right? Lowest root mean squared error is that. Okay. So we have our plot of that. Cool. Of it tuning. You can see that's probably, you know, the max, the best parameter. We can also just look at it like, okay, look at the MAE. On average, when it has 6, when it uses that parameter of 6, it's off by 1.7. Cool. Okay. So now let's do the evaluate the tidy model. So with the tidy model, we look at TidyTune. There's actually some cool things that you can do. So we can say select best, and we say, okay, with the metric, we want the best RMSE. And it does that, right? It says mtry of 7 with a min n of 33. So that's our best tuning, right? Tidy best tune. Cool. So now we actually want to kind of like finalize our model. So let's say finalize our models. We already know that our Caret RF, we can just say final model. See, it says numTrees 6, yada yada. And it'll automatically kind of choose the best model, basically. See, it says final model is that. So we kind of don't have to worry about the Caret one. However, for the tidy way, we can say we have to do a different thing. Okay, so we say, if we look at our tidy RF, it doesn't actually have any tuning parameters since we were trying to tune it based off the tidy tune. So we're gonna have to add these new tuning parameters from our tidy best tune, right? So if we look at tidy best tune, it has it, right? mtree and min n, so we need to give it that. Okay, so we're gonna do this. We're gonna use a function that they were smart that they knew that people were gonna be using, right? They know people are gonna be tuning models, and they want to apply that final tuning parameter to their model. So this function is called the finalize model. We give it our original model, and then we give it the new parameters, which is tidy best tune, and boom, you see it's updated to 7 and 33. Okay, so let's say tidy final model. Cool. So once we have a tidy final model, we have to make an actual a final workflow. Since we were training off of our workflow, we need to create another workflow because our model is different, which is a little confusing, to be honest. And I'm sure there's a reason for it. But if you notice that with the tidy, oh my, why do I always delete this? If you notice with the tidy models, there's so much things to read about. And since they just released it, it's going to be kind of, it's going to take a few months for everyone to kind of like figure out the process. They're probably going to make some fixes. They're going to probably make some changes to the function names and all that stuff. Okay, so we need to make a final workflow. So we'll say tidy final workflow. workflow function, add recipe. It's still the same recipe, but this time we add a model, and this is our tidy final model. Okay, and if we look at our tidy final workflow, what's it saying? It's saying, okay, we're going to pre-process it using our given recipe. Our model is a random forest. We're going to center scale and dummy it, and we're going to give these parameters. Okay, so we're going to say tidy. So now we need to actually know, like, okay, so we have our final model. We need to test our actual models, right? So let's say that. Let's say evaluate the test sets using the final models, right? Easy. So for Caret, it's a little weird. So if we do some predict, Caret RF, which is our final model with the Caret test, it gives you a list of all this garbage, right? So we always have to convert it to like as a table, right? And we'll cbind our Caret test as table, select rings, and we'll say obs equals that, right? So obs equals that as that table. I'll say select, and we'll say pred equals 1. Okay, so we have our final model. We have our pred 1. You see, it's kind of looking right, but this one's obviously very wrong. But we'll say that. So we'll say Caret final results, and we are gonna evaluate through RMSE. We'll use Caret's function for RMSE for the Caret stuff. So our pred is equal to Caret final results pred. Our observe is Caret final results observed, and we calculate it's 2.29. Does that make any sense? Since realistically a good model should basically have this similar validation and test accuracy. So let's look at it. So Caret RF, right? Caret RF 2.34, 2.29. I think that's pretty solid. In fact, it's a little bit lower. Cool. So now let's say evaluate. So this is a Caret way. Caret way. So for the actual tidy way, and we'll we'll delete that because we don't really need that stuff. Okay. And finally, for the tidy way, we still have our tidy model, our tidy workflow. What's cool about this is they know, oh yeah, like we're gonna have to evaluate on the test set. There's also this cool function called last fit, which is our last fit. We did all of our modeling tuning. This is our last fit. We finally are gonna put it to the test set. And to actually give it, to find the test set, we're actually gonna use the tidy split, right? And it actually evaluates on the test set. So we have our trained test split like that. Okay. And then we can actually do is collect metrics, and boom, we have our test metrics from our test set. Right. So it's pretty straightforward, and we see, oh, it's 2.44. So we notice that 2.29. So our actual Caret is a little bit better, but still, we actually didn't give it as much tuning parameters. With random forest is gonna the Caret way took a lot longer than the actual tidy way, and we can always do more tuning. Okay. We are specified the trees, but if we let it kind of tune the trees too, I'm sure it would find a better model. But if you notice something, how it's definitely pretty easy to evaluate these models that in the tidy way, but the actual modeling procedure seems a little bit more complex. And that's because I think it's really made to train multiple models at the same time with the same procedure on the same data. Additionally, I think some problems with the tidy model package is that there's a lot of functions that you just like. It makes sense, but there's so many ways to say it that you're like, I don't even know how, like, what function I'm really looking for. So there's gonna be a lot of referencing the actual package. But that's fine because they made some great documentation. Additionally, the tune grid is a little confusing with the workflow. I think I still need to kind of really understand how the workflow works. But the really good things that I like about the TidyModels framework is that they really make it so you can't really mess with the test set. So it's they're really trying to make it so like you're not cheating on your actual modeling procedures. So yeah, this is basically a short video of just kind of going over the basics of the TidyModels and Caret package. One thing that I think would be kind of interesting to do is basically a good I think a good way to kind of dip your toes into it is really kind of learn the recipes package, right? And do all the pre-processing using recipes like this and then just juicing it like that. So doing up to this step. And then if you don't feel comfortable doing, say, the tidy model part, you can just use the juiced data on your Caret stuff and just train models through Caret. I think that's a good way to kind of start getting a hang of how the tidy models works. So yeah, this is just a short video, but I really like the tidy models package, and I'm probably going to keep on working on it. Probably also probably make a video on the Keras package because the tidy models really reminds you of Keras too. So we might be messing with that in the future. So yeah, yeah, I'll see you guys next week and tidy on.